All right, hey algebra kiddos. Here we are looking at excuse me, notes for 2-8, simplifying radicals with variables. So in our last lesson we looked at 2-7, just simplifying radicals with numbers in them. This time we're going to add in some variables. So we were looking for perfect square factors. That's still what we're doing here. We're still looking for the largest perfect square factor. And remember, when we talk about factors, that's referring to multiplication. Okay, so when we look at perfect squares, and we're talking about variables, we know that we have our perfect squares like 16, 25, 81, those. But variables, it's a little bit different. So we know from our work in those little baby equations, like when I have x squared is equal to 36, I can undo that square by taking the square root to get x. So we know that the square root of x is equal to x because a square root undoes a square. So then if we have x to the fourth, how many x squareds could we break that up into? Well, we could break x to the fourth up into x squared times x squared, right? X squared times x squared would get me back to that original x to the fourth. Well then, I know from basic math that we learned earlier about the square root of x squared becoming x, that the square root of x squared is going to turn into x, and the square root of x squared again is going to turn into x, and x times x leaves me with x squared. Similar kind of process here with the x to the sixth. How many x squareds can I break up x to the sixth into? Well, I could do x squared times x squared. That would get me back to x to the fourth, times another one would get me back to that x to the sixth. And I know that the square root of x squared is x, the square root of x squared is x again, and the square root of x squared again is, I think I said that wrong, and x times x gives me x to the third power. So then, if I jump down and skip this pattern and go all the way to x to the 20th, how many x squareds can I break up x to the 20th into? Oh my goodness, excuse me. Ugh. Well, that would be 10 of them, because x squared times itself 10 times would get me to x to the 20th. So, really, what I'm doing with all these exponents when I'm taking the square root of them, 2 to get to 4, 6 to get to 3, I end up just taking that exponent and cutting it in half. So here I end up with x to the 10th, because I would split that up into x squared times the square root of 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 x squared, 2, 4, 6, 8, 9. Oh my goodness. Square root of x squared, square root of x squared, 2, 4, 6, 8, 10, 12, 14, 16, 17. You get the picture. We can kind of put a little etc. dot dot dot. And so then if we're keeping that pattern going around, we're just taking half of it. So if I look at one other example, let's go the square root of x to the 10th. Well, that would get you x to the 5th. You're just taking those exponents and cutting them in half when you're taking the square root of them. But notice, though, our exponents in all of these, the 2, the 4, the 6, the 20, the 10, all of these exponents are even. So even exponents are considered perfect squares. So even exponents. Even exponents on variables are perfect squares. That's why you're looking to see how many x squareds you can break something up into. So then that leaves the question, well, I guess we'll end there and then we'll talk about odd exponents in the next part.